দেখো মিডল পয়েন্ট কোনটা আছে, টোটাল হাইটের মিডল পয়েন্ট, টোটাল হাইট কত 60, তো 60 সেন্টিমিটার মিডল পয়েন্ট কত আছে দেখো 30, তাহলে এর হাফ হচ্ছে 30, তাহলে হাফটার রেঞ্জ ম্যাক্সিমাম হবে, এটা হচ্ছে আর ম্যাক্স। ওকে, ওয়ানের দেখো স্পিড ভেরি হাই, ম্যাক্সিমাম স্পিড কার হবে, ভেলোসিটি অফ ইফ্লাক্স 1, কেন ডেপথ অনেক বেশি আছে, কত 50 সেন্টিমিটার, বাট এটার নিচে আর জায়গা নেই যে এটা সামনে যাবে আরো, বিকজ ইট ইজ ভেরি ক্লোজ টু দ্য গ্রাউন্ড। আর এর প্রবলেমটা দেখো, এর প্রবলেমটা হচ্ছে স্পিডটা ভেরি লো, বাট এর অনেক জায়গা আছে টু ফল, সো দিস টু উইল হ্যাভ ইকুয়াল রেঞ্জ। আর আইডিয়াটা কি বললাম, if the two orifices, they are cut at same distance from bottom and free surface, নিচ থেকে যত ওপর থেকেও তত, then they will have equal range. It is a theory, we can prove this. তাহলে এর নিচ থেকে কত সেন্টিমিটার 10, আর এর ওপর থেকে কত সেন্টিমিটার 10, তাহলে these two orifices will eject liquid having same range. এর নিচ থেকে হাইট কত 20, আর এর ওপর থেকে হাইট কত এইটা 20, these two will have same range, আর মিডল একটা ম্যাক্সিমাম রেঞ্জ, এটা হচ্ছে মানে। চলো নেক্সট পার্টে যাই। নেক্সট পার্ট ইজ অ্যাপ্লিকেশনস। বার্নৌলিস থিওরেমের এই এক্সাম্পলগুলো আসতে পারে শর্ট কোশ্চেনে, আর না হলে কিসে আসতে পারে না এক্সপ্লেন 2 মার্কসের। তো চলো নেক্সট পার্ট ইজ দিস ওয়ান, অ্যাটোমাইজার। এসি আর জেডি আর যা লিখবে, অ্যাটোমাইজার। অ্যাটোমাইজ করা মানে व्हाट इज एटोमाइजर? एटोमाइजर इज, मेरे साथ साथ ड्रॉ करो, दिस इज अ बलून और अ बॉल दैट कैन बी स्क्वीज्ड इजीली, ऐसे स्क्वीज कर सकते हैं। नाउ हियर इज अ ट्यूब, जिसका नीचे और एक ट्यूब है, डेटॉल हैंड वॉश, एनी डिओडोरेंट, स्प्रे, सलून, एवरीवेयर वी यूज इट। The principle of atomizer. What happens now? Let me fill it with some liquid. Here is some liquid. Okay. Here is nothing but air. Now, if we squeeze this to this volume, so the air from here, here or here, they run through this tube. These air molecules are moving so fast through this that if you consider a point P here, then at P, velocity is very high. Velocity of the fluid flow is very high. So is half v square. Remember Bernoulli's theorem? Sum of pressure energy, kinetic energy and potential energy per unit mass is constant. That was Bernoulli's theorem. So as the flow is horizontal, P by rho half v square equals to constant. GH का क्या हुआ? GH तो already constant, height तो constant horizontal flow में. So P by rho plus half v square is constant. If half v square is very high, then P by rho, that is pressure, is very low. Remember Bernoulli's theorem. This is the principle. Pressure energy and kinetic energy sum is constant for horizontal fluid flow. We have done this. Now out of this is one, if one is very high, say kinetic energy, then the other has to be less, pressure energy. So at P, kinetic energy very high, pressure is very low. On the other hand, I had told you that if any liquid is exposed to air or open to air, as is this pink color liquid, then P ATM will act through that. Atmospheric pressure will act through that. That is normal pressure. So this atmospheric pressure is also acting like this. P ATM. So if you consider a point here, the pressure is P ATM. That is, let us consider this point to be Q. So at Q, pressure equals to P ATM, atmospheric pressure. Compare P and Q. Q is at a higher pressure. This is small p, pressure. And P is the point, capital P. So at Q, pressure is equal to atmospheric pressure. That is, pressure at Q is much greater than pressure at P. P is a low pressure zone. We create a low pressure zone by moving the fluid very fast at that point. That is the idea. Idea को समझो, याद रखो. So high speed, low pressure. That's it. Low speed or no speed at all, high pressure, that is atmospheric pressure. So liquid will start flowing from high pressure point Q to the low pressure point P. Liquid will start flowing in this direction. So as the liquid starts flowing in this direction, after reaching P, there are further air molecules which are on the way moving through this. So those molecules pushes this liquid further in this direction. As a result, the liquid scatters in all directions. This system is called atomizer, and it works on the principle of this, Bernoulli's theorem. So if it is asked, the principle of atomizer is based on Bernoulli's theorem. And this is the working of that. In same way, if suppose a person sitting being very sad on a stormy night, closing all the windows and doors of his house without knowing Bernoulli's theorem, and it is a stormy night, high speed air is blowing, what happens that if we consider any point here, P capital, at P, velocity V is high. Same logic, half V square is also very high. Storm is coming, is passing. So P by rho is very low. So pressure low. P is a low pressure zone because high velocity zone means low pressure zone. V is high. Low pressure zone. Consider a point inside the house. Say inside the house there is a point Q. And inside the house, as all the windows and doors are closed, so velocity nearly equal to 0. No air is moving or flowing inside that room. So if velocity is nearly 0, so at Q, pressure energy would be very high compared to Q. P compared to the point P. That is, pressure is higher and the difference is so much. ये टीना का चाला हुआ ना अगर, if it is a loose shed, then this shed will blow off in air. चाला उड़ जाता है फिर, तो उपाय क्या है? उपाय ये खिड़की खोल दो, so that velocity inside and outside becomes same, the pressure difference nearly becomes same. और खिड़की अगर खोल दोगे उसमें ग्रिल होना चाहिए, नहीं तो द पर्सन विल ऑल्सो बी ब्लोन ऑफ इन एयर. घर बच जाएगा, आदमी नहीं बचेगा. एंड फॉर सेम रीजन समृद्ध किक्स अ बॉल in such a way, corner নিচ্ছে সমৃদ্ধ kicks a ball in such a way that this ball is rotating in this sense. So we know that if this radius is r, velocity at this point will be Vcm plus r omega. But at this point, it would be less. How much? Vcm minus r omega. VCM तो every particle will be having VCM, center of mass of velocity. ऊपर वाला पॉइंट होगा VCM plus r omega, नीचे वाला होगा VCM minus r omega. Let us again consider this point to be P and this point to be Q. So same logic also holds here. At P, velocity is high, kinetic energy is high, pressure energy low, and at Q, velocity is less. To some extent, but less. But that does enough thing. क्या enough thing? To make a goal during corner. So what happens? This is the direction of motion of the football. How much? VCM. Center of mass of velocity, VCM. And let me show you how pressure creates a difference here. Here is the pressure at P, downward. And here is the pressure at Q, upwards. Why is that? Why isn't pressure at Q downward? It is downward. It is pressure acts in all the directions like this. Now we draw the only direction where the object lies. So about point P, P तो नीचे है एक point. So with respect to Q, about the point Q, Q तो नीचे है. So with respect to Q, the ball or our matter of concern, the subject of concern is above. That's why we have drawn above the direction of pressure. Similarly, P lies here. So the object to be considered is below this. That's why we are considering pressure below or downwards. So this is small p at capital P point and this is small p at Q point. So as PQ is greater than PP, so there would be a net pressure in this direction, PQ minus PP. So the ball moves in this direction also. Why? Because force is given by, remember, force is given by difference in pressure into area. We have done this in class 9. Pressure equals to force by area, so force equals to pressure into area. So there would be a force on the ball in this direction which is perpendicular to original motion. Original motion x-axis में VCM, but it will experience a force in y-axis. So the ball finally moves like this. As a result of these two, resultant ऐसे करके बॉल मुड़ जाएगी किसका तरफ? गोल पोस्ट का तरफ. और क्या हो जाएगा? गोल. मैग्नस इफेक्ट, इसका नाम लिखो. दिस इफेक्ट इज कॉल्ड मैग्नस इफेक्ट. একদম জাস্ট এটাকে টাইপ করবে ম্যাগনাস এফেক্ট. তোমরা তো অবশ্য মোবাইল ফোন ঘাঁটো না, ইউ আর ভেরি গুড বয়েজ. তো যদি ঘাঁটো একটু দেখবে, অন্য জিনিস না দেখে সেটা হচ্ছে ম্যাগনাস এফেক্ট টাইপ করবে. কোথায়? ইন ফুটবল. তারপর দেখো তা মনে রেখো, হ্যাঁ, ম্যাগনাস এফেক্ট টার্মটা মনে রাখবে। যদি তোমায় এটা জিজ্ঞেস করে যে ম্যাগনাস এফেক্ট ইজ আ কনসিকুয়েন্স অফ, চারটে থিওরাম দিয়ে দিল, স্টোকস ল, বার্নৌলিস থিওরাম, নিউটনস ল, ভিসকসিটি, আর এটা বললো অল অফ দেম। তো এমসিকিউ অলসো, যাকে চলো। সো দিজ আর দ্য অ্যাপ্লিকেশন। হ্যাঁ, হ্যাঁ বলো, মডুলাস, yes, yes, answer would be Bernoulli's theorem. Pressure difference. Bernoulli's theorem actually does what? Or whenever you get the chance, write these equations. Very easy, but this strengthens your answer. This holds good only for horizontal flow, but this is not a horizontal flow. The 2 points are a little up by diameter of the football, the gap between the 2 points. Still, we neglect the diameter of the football and we consider P and Q both lie on the same horizontal line. That's why horizontal flow. Wherever we will get a chance, we will neglect the gap between the 2 points and make it a horizontal flow. Like last point of this, airlift or lift of a, airlift मत लिखो, मूवी बन जाएगा, lift of airfoil and try to draw an airfoil like this, like this. This means what? This means, I mean to say, इसका स्पेशलिटी देखो, I mean to say, पहले मैं बता दे रहा हूँ, then you draw that, maybe that is better, otherwise you can also draw. देखो, if you consider these to be air layers, at regular intervals, what happens when this thing moves forward? This shape, this is called a foil, this moves forward. So these air layers with respect to this move backwards. So this moves backward with no effect because it is much away from this. This also moves backward. But what happens, suppose this air layer has no other option than to flow through this being squeezed. Like this. And these air layers move like this. Look at these two layers, one above the foil and one below the foil. This is an area above this foil. This is called a foil, this one, this shape. This is an area above the foil, this area, and this is an area below the foil. If we call it P and if we call this Q, so at P, this is a writing style I want you to adopt. What writing style? Just write some points and then take the points sideways on your copy and tell something about them. It becomes brief. Only you need to do this, draw this picture. But first understand, then you will understand why and how to draw this. At P,
Sir, but repeat this thing once again, I couldn't understand this.
what thing? Tell me.
Like for the points, like where the bulge is present, how is it getting diverted?
No, actually this is moving in forward direction. This is moving.
Oh, okay, sir.
this is moving in forward direction. So suppose you have taken a balloon and you are trying to push the balloon in air like this. So the air in front of that will have to make their way below or above that balloon, isn't it? Because it cannot enter the balloon directly. So suppose this is a balloon like thing, okay, and from this direction there are air layers. So as the balloon is moving in this direction, the air layers have got nothing but to move like this, isn't it? Now understand? Okay. Okay. But we have made the shapes in such a way, shape of this foil in such a way that the air layers which are forced to pass above this shape through a very small area. So area smaller, and try to use these comparative degrees. Okay, in place of small, write smaller. Even if I have written it earlier, change that, because we are trying to just compare them. Okay, area smaller at point P. So if area is smaller, velocity more. Why? Area into velocity constant, equation of continuity. If velocity is more, half v square is more. If half v square is more, p by rho is less. That means low pressure zone. So I have written lower, not low. So it would be at a lower pressure zone, P point. And whenever, if you use P and Q point, please use small p to express pressure, because capital P is a point anyway. So small p, that is pressure at point capital P, this region would be lower compared to the point Q. Lower compared to, otherwise you can write like this, lower, therefore small p at P point is less than small p at Q point. Ayushman, this now you understand? Tell me this.
Yes.
Huh? This much understood? Okay. So pressure at P would be less than pressure at Q. Now how to show pressure? Students sometimes face problem while representing these things. Pressure. The direction of pressure through at this point would be upwards or downwards. P point में pressure upwards होगा ना downwards होगा. P point lies above this foil and we want to find pressure on this foil. So pressure at P will be downward because the object lies downwards. So the pressure in this region P would be downwards. This is P at P. Similarly, what about Q? With respect to the point Q or the section we have considered around Q, that section lies below the foil. So our main objective is to find pressure on this foil. So pressure on this foil with respect to Q would be upwards because the object lies upwards. So this is P at Q. And this is the result we got. P at Q is more than P at P. That means there would be a pressure difference, delta P. How much? P at Q minus P at P. So write, due to this pressure difference, the foil lifts upwards. क्योंकि ये ज़्यादा है Q, upward pressure more, downward pressure less. So ultimately this thing will move up. But it has to move in forward direction. So ऐसा shape को, if you make any shape like this एंड इफ यू मूव इट फॉरवर्ड, तो ये सामने अगर जोर से लेके जाओगे तो इट विल कंटिन्यू इन फॉरवर्ड मोशन, कंटिन्यू इन मूविंग फॉरवर्ड डायरेक्शन, एज वेल एज ये ना ऐसे करके ऊपर उठ जाएगा. दैट मीन्स इट्स मोशन वुड बी समवट लाइक दिस. सामने भी जाएगा, ऊपर भी उठेगा. ड्यू टू दिस प्रेशर डिफरेंस. और यहां पे भी सेम फॉर्मूला अप्लाइड होगा. इफ यू फाइंड एनी न्यूमेरिकल, दोज हु आर फ्रॉम CBSE, from NCERT, you will find good example of this thing. So for that, doing numerical, for ISC also there are so many numerical. For doing numerical, force is given by change, difference in pressure P and Q का into the area. Area समझ में नहीं आ रहा, कौन सा area? ठीक है, I'll explain this. So this much you have written. বলো তাহলে শুড আই গো টু দ্য নেক্সট পেজ, মানে ফ্রেশ করে এবার এটাকে দেখাচ্ছি. এইগুলো লিখে নিয়েছো তো, ভ্যালুয়েবল থিংস, ব্রিফ এন্ড একদম ছোট করে দিয়েছি এগুলো. ঠিক আছে, চলো নেক্সট পার্ট এইটা দেখাচ্ছি. মানে উই উইল কন্টিনিউ দিস ফর আ মিনিট. দ্যাট ইজ ইফ দিস ইজ আ শেপ, दिस इज अ शेप, और मेरा आर्टिस्टिक वो तो जानते हो तुम लोग. This is the cross section of the wing of a bird. This shape. A bird when expand this in air, तो देखने में कैसा होगा? We have just imitated that when we make aeroplanes. अगर साइंस सिटी जाओगे, लेफ्ट साइड में किया हुआ है ऐसा, यू कैन सी दैट, यू कैन मूव दैट, और उसका स्पीड चेंज करके और एंगल चेंज करके यू कैन एक्सपेरिमेंट ऑल्सो. साइंस सिटी में दिया हुआ. ये एरोप्लेन कहाँ से बन गया? नाउ यू सी दिस व्हेन यू हैव ग्रैब्ड अ सीट ऑफ, आई मीन अ विंडो सीट. विंडो सीट में अगर बैठे हो प्लेन में, तो ऑब्वियसली यू हैव सीन द विंग ऑफ दैट एरोप्लेन लाइक दिस. ये एरोप्लेन का विंग है एक्चुअली, ये साइड व्यू है विंग का. तो एरोप्लेन कहाँ गया? एरोप्लेन ऐसा है, ये साइड व्यू है, एंड दिस इज द एरोप्लेन. ये उसका विंग है, ये सेकंड विंग ऐसे. एरोप्लेन बहुत ही खराब टाइप का है, अभी मौसम खराब होने के कारण ये ऐसा हो रहा है. ये कॉकपिट है, ये ऐसा है, पैसेंजर्स. হ্যাঁ করেছি কি বলতে পারছি না, তবে আই ট্রাইড হার্ড টু ড্র অ্যান এরোপ্লেন. এটা নোজ অফ দ্য এরোপ্লেন, দিস ওয়ান ইজ. আই জাস্ট ওয়ান্ট টু হাইলাইট দিস থিং. এইটা বাবা করে নাও, এইটা অ্যাজ দ্য, আচ্ছা ঠিক আছে চলো, তোমাদের পছন্দ হচ্ছে না, আমি চেঞ্জ করে দিচ্ছি. আমি একটু ভালো করে ড্র করতে চেষ্টা করছি. কোথায় গেলি? এই যে. সো ইফ আই কল দিস টু বি দ্য wing of the aeroplane, এটা. So an aeroplane is like this. These are the wings, and this is the cockpit. Now as the aeroplane moves like this, this section also moves like this. So there is a point here P, and there is a point here Q. As it moves like that, the air layers, they come from this side like this. These are the air layers moving in this direction. Remember, I had drawn these air layers. So as this thing happens, we just saw that pressure at Q was greater than pressure at P, just here. See this? This is the wing of that aeroplane, and this is that foil. So as it moves, the air layers do this thing. Okay. So what happens? Pressure at the lower part, P at the point Q, pressure on the from the upper part, P at P. Which one is greater? Q. So it gives it an upward force. Force was given by what? Difference in this pressure into area. And now area is here, this A is the total area of the wings, this one and this one. Well, A means area of the wings. Let me draw this. Chalo, draw karo. This is a solid surface. Now this part is easy. I am scoring for you and very important for your exams. Suppose this is a solid surface. छोटा करके draw करो. This is a solid surface. Now this is a liquid layer flowing through this. This is another liquid layer. And a liquid molecule. They are so close that they will attract each other very strongly. But think of this liquid molecule and a solid molecule. The distance is more, less attraction. Think of this liquid molecule and a solid molecule. Distance further increases, less attraction. Less attraction. So the force of intermolecular attraction between these two is the least, and between these two is strongest. That means all the liquid molecules, these molecules of the liquid, they have a solid, strong attraction intermolecular with these solid molecules. Isn't it? That's why this layer, write this line, layer in contact with the solid surface does not move. That is the idea. Does not move over the solid. So this liquid layer has no velocity with respect to the solid. This liquid layer has a little more velocity, and this liquid layer has the maximum velocity while flowing. That means, what I mean to say, if we take a section, this is a section, this liquid layer would be having maximum velocity. So if we draw their velocities with vector heads, arrows, so that will have length maximum. And the velocity of the other parts of the liquid or layers of the liquid will go on decreasing. Its velocity would be somewhat less. Its velocity would be somewhat less, somewhat less, somewhat less, like this. Why? Because the intermolecular attraction is maximum for the layer directly in contact with the solid and goes on decreasing as we move away from the solid surface. So the liquids feel free to move over the solid. That's why all the liquid layers do not move with same speed. That is the idea. And if we join their velocity heads joined to form, इसको क्या बोलते हैं? वेलोसिटी हेड्स को अगर ज्वाइन कर देंगे तो ये डॉटेड लाइन इज कॉल्ड टू फॉर्म velocity profile. The outer line of this velocity, how their velocities are changing, is called, dotted line is called velocity profile. So we understand basic fact from here. For a liquid flow, and any liquid we will consider is viscous. Now, second thing for a short question, that is, if we consider a liquid flow, there is a solid surface, just draw like this, there is a solid surface, these are the liquid layers, and if we take a section, this is a section. So the velocity heads, I am drawing another type of velocity heads. Arey, what is happening? All the velocities of same length. चलो लिख ही दिए. यहाँ पे और क्या बाकी है लिखना?
Non-viscous.
Yes, this is non-viscous liquid flow, which has no stickiness. That means all the layers will move with equal velocity, and the velocity profile here becomes a straight line. You may be given 4 pictures to detect the correct picture for a correct flow. So this is non-viscous liquid flow. And now if I draw this thing, then tell me whether you have seen this or not. It is a narrow neck liquid bottle which contains a liquid which is very sticky. Let us take an example of honey. You have a narrow neck bottle of honey. You are trying to pour honey out of it. Its profile looks like this. But its profile doesn't look like this. It never looks like this. Honey comes out of the bottle like this. Does it happen? No. So is it velocity profile straight line? This velocity profile? No. Its velocity profile is like this. You have seen this. Why this? Because if I now draw 2 solid surfaces, then we can understand that the liquid layer at the middle will be at maximum distance away from solid surfaces. 2 surfaces are solid. अगर ऊपर उड़ गए तो इसका पास हो जाएंगे, नीचे आएंगे तो नीचे वाला solid surface का पास आ जाएंगे. So the liquid layer in the middle will enjoy least intermolecular force compared to, exerted by both the solids together. So this liquid layer will flow with maximum velocity. but the liquid layer in contact with this solid will not move, and the liquid layer in contact with this solid will not move either, and the other layers will move, okay, but with some restricted velocity. That means the liquid velocity profile would be like this: zero velocity, maximum velocity of this layer. So the liquid layer will be like this: 0, 0, and in the middle maximum. So its velocity would be like this. Its velocity would be like this. Doesn't it match with this one? It is just tilted vertically. It is straight. इसको मैं अगर tilt कर दूंगा ऐसा ही दिखेगा. If I tilt it like this, it will just look like that. See that? And this is solid. This is also solid. So now we understand why liquid behaves like that. Especially the sticky ones. Sticky ones means more viscous. Okay.
Sir, kintu doron jodi toothpaste try, Colgate toothpaste.
That is not a, that is a semi-solid or semi-liquid, you can say. Semi-liquid. है ना? That's why. बोलो. हाँ যাচ্ছি. দেখা যাচ্ছে পুরো স্ক্রিনটা দেখতে পাচ্ছ? ওকে, ঠিক আছে. ওকে, চলো নেক্সট পেজে যাই. Now, if we consider this Newton's laws heading the direct understanding part, concept building part. Otherwise, other than these concepts, if you don't know these concepts, you cannot understand this directly, Newton's laws. So give heading Newton's laws. Newton's law of motion मत लिख देना, Newton's law of viscosity. Newton's law of viscosity. That is, draw a layer like this. This is a layer of a liquid. This layer, two-dimensional, just like a page of the copy. बहुत अच्छा ड्रॉ नहीं हुआ. अब तो बेटर है. Now this is another liquid layer I am going to draw. ছেড়ে দাও, ওটা অন্য ড্র করছি, হাতেই করছি. চলো, this is another liquid layer and this is the solid surface, right? Solid. Okay, this is a solid surface. Okay, हो गया. Now if this liquid layer moves with a velocity v, this liquid layer must be moving with a velocity little greater than v. Why is that? Who says that? Why is this liquid layer having more velocity than the previous one? Logic? Very good. If this is x away from the solid surface, obviously another liquid layer considered is a little more distance away than the solid surface. dx extra distance, dv extra speed. We understood that from the last theory. So here give a star and write this. Give a star here and write this. dv by dx is called velocity gradient. Velocity gradient. You know what gradient means, you have done in mathematics. If one quantity changes depending on other, then we understand that for an extra height dx or distance dx, an extra velocity dv becomes. So for one height increase, it will become dv by dx. So increase in velocity along the distance x or increase in velocity per unit distance, that is called velocity gradient, how velocity changes with x. Okay. Now comes the hero of this chapter, depending on what you would be doing rest of the part of the chapter. That is, if there is a relative velocity, this is again for understanding, not Newton's law. Understanding, asterisk means understanding. If there is relative velocity between liquid layers, अगर लिक्विड लेयर्स के बीच में रिलेटिव वेलोसिटी हो गया, an opposing force acts between the layers in opposite direction of the rel-vel. So if there is a relative velocity between two liquid layers, their relative velocity will be opposed, just like friction in case of solids. Relative velocity will be opposed. Where will it act? In which direction will it act? It will act between the two layers. And the relative velocity, that means V said V plus dV is dV extra than V. The relative velocity extra सामने है. So there would be an opposing force in opposite direction to the relative velocity, माने extra velocity. This is called viscous drag. This is called viscous drag. So the viscosity drags or tries to drag the liquid layers by saying, भाई एक साथ चलो, relative velocity लेके मत जाओ. अगर जाओगे तो मैं तो रोकूंगा फिर. I'll oppose any relative velocity, and it does so by applying a force F. This is the picture. This is the meaning of viscous drag. This force. Okay, you have written this, understood this. So this is an area considered which has both are of equal area A. Actually, दोनों का area कितना है? A. So according to Newton, let us go to next page. So now the Newton's law. According to Newton, the viscous drag is directly proportional to this area. Unlike solid friction, this is another question may come. What is the difference between solid friction and liquid friction? That is viscosity or viscous drag. The only difference is this: solid friction does not depend on area, it depends on the nature of the two surfaces in contact. We did it in static friction, laws of static friction. But liquid friction depends on the area of the surfaces in contact, liquid layers. And it also depends on the velocity gradient. It means what? Velocity gradient is easy meaning is what? Easy meaning is that if I dip both my hands in nariyal tel, then I got some liquid film sticking to my hands. Now if I want to rub my hand one over the other with some relative velocity, we can feel a resistive force offered by those liquid layers in opposite direction, because when you are moving hands, actually you are moving two liquid layers stuck to your hands with some relative velocities. And ये relative velocity अगर सामने है So viscous drag will act between those two layers in backward direction. And if it is Fevicol, then if you want to move your hand that is more viscous, you will feel more viscous drag in opposite direction. That viscous drag F is proportional to the area. That means if you reduce your area of the hands by touching two fingers only, and then if you want to make some relative velocity between two fingers, you will face less viscous drag. And if you increase the area by taking whole hand together, both the hands, then area increases, so more viscous drag backward. Second thing, if you want to, okay, area अब सेम ही है, इतना है. अब एक बार ऐसे किए देखो. First case, I am trying to drag, move this force hand slower. Now second case, I am trying to move this hand faster. I'll be offered more viscous drag. So देखो, we make use of these things in different cases. In engineering, fluid mechanics is there. But I am giving you an easy example, not related to this, but similar to this. How? Seat belts. Seat belts. When you engage the seat belts like this, you pull it slowly, less force is offered by the seat belt to expand. You want to pull it with a sudden jerk, more force is offered by that seat belt. Similar manner, this thing happens. More the velocity dV, more the velocity gradient. That is, faster the layer tries to move over the other layers, more will be viscous drag. That is whatever is velocity gradient. Otherwise, see this, velocity gradient has unit, meter per second, that is dV, and dx is what? Meter. So meter, meter cancel, it is 1 by second. Anyway, just for an example. So Newton's law says that these two are proportional to viscous drag. So viscous drag is equal to a constant eta, now comes eta, coefficient of viscosity, into these two things. Now this is Newton's law, done. This is Newton's law of viscosity. Eta is a constant, this is called coefficient of viscosity. Coefficient of viscosity, which can be found from this equation as this: F into dx divided by area into dV. Now dimension of force, ml t to the power minus 2. If we want to find dimension, dx L, area L square, dV velocity L t to the power minus 1. This gives us m L t. याद रखने के लिए मैं डायमेंशन चैप्टर में भी बोला था, एम एल टी लिख देना, लास्ट दोनों का -1 -1. यस, वेरी गुड. लास्ट दोनों का -1 -1. This is very important, dimensions of coefficient of viscosity. And its unit. Its unit will be Newton per meter square, area per meter square, and dx by dV. dV by dx is 1 by second, so dx by dV would be second. Newton per meter square into second. If it is given that this is a glass block that is placed over a table, very common type numerical, very common type. It is not hanging in air. Actually, there is some liquid spread on the table, and that liquid layer is very thin, we cannot see them, but that is present. This is the liquid layer. This liquid layer is 10 millimeter, yes, okay, 10 millimeter thick. area of the plate is 10 centimeter square. So how much force should we apply, F external, to pull it with a velocity of 1 meter per second? V equals to 1 meter per second. If eta is 10 to the power 2 Newton second per meter square. So the answer is very simple. F equals to eta A dv by dx. Eta 10 to the power 2, area 10 centimeter square. So 10 into 10 to the power minus 4 meter square. SI सिस्टम dv. अब देखो dv का माने क्या है, तो मैथमेटिक्स में ठीक है, फिजिक्स में इसका एप्लीकेशन सोचो. The layer with the table is not moving, that is stationary. I told you the layer in contact. But the layer with the glass, that is also not moving with respect to the glass, but this is a glass plate. The layer with the glass, that is also sticking to the glass, but as the glass plate is being moved, so can we say with respect to the lowest layer of the liquid, the uppermost layer of the liquid is moving with the glass? कितना एक्स्ट्रा स्पीड लेके, लोएस्ट वाला तो जीरो है, और अपर मोस्ट प्लेट दैट इज ग्लास, वो जितना स्पीड लेके जा रहा है, द लिक्विड लेयर स्टिकिंग टू दैट इज आल्सो मूविंग विद द सेम स्पीड. दैट मीन्स देयर इज अ वेलोसिटी डिफरेंस ऑफ दिस मच ओनली, 1 मीटर पर सेकेंड. सो dv मीन्स 1, dv सिर्फ dv का वैल्यू बैठा है 1, एंड dx मीन्स व्हाट इज द डिस्टेंस बिटवीन दीज टू लेयर्स जिसमें dv हो रहा है 10 मिलीमीटर. 10 मिलीमीटर मीन्स SI सिस्टम में करेंगे, मीटर बनाओ. सो 10 into 10 to the power minus 3, that is 10 to the power minus 2. बस हो गया. दिस इज आंसर, दिस मच न्यूटन. सो यहां से क्या सीखने को मिला, दिस स्ट्रक्चर्स जो दिख रहा है ना, इससे लग रहा है बहुत टफ कुछ दिया हुआ है, बाकी व्हेन यू आर गोइंग टू पुट द वैल्यूज एवरीथिंग इज गिवन, सिर्फ थोड़ा सा यूनिट चेंज कर लेना है. एंड अनदर थिंग you have to understand dv means the velocity given, उसी को dv ले लेना, और dx means thickness of that liquid film or layer. बस after doing this practical idea हो जाएगा. So it becomes equal to 10 Newton or what? ना 10 Newton ना 10 Newton, हाँ 10 Newton, ठीक है, right on. So the viscous drag is 10 Newton. Now this sum can be made a little more critical. Idea same, application same, formula भी same हो जाएगा, सिर्फ स्टूडेंट का दिमाग में प्रेशर बढ़ जाएगा. कैसे? अगर ये F एक्सटर्नल डायरेक्ट कोई आदमी ना टान के यहां पे लगा दिए क्या, पुली, एंड दिस थ्रेड passes over this, बोलेगा भाई m मास कितना होगा so that it starts moving. सिंपल है, जितना फोर्स मिला ना F, दैट इज 10 न्यूटन, ताहले M into G should be equal to this 10 न्यूटन. M into G, इसका वेट ही तो टानेगा. दिस वेट mg नाउ एक्ट्स इन प्लेस ऑफ F एक्सटर्नल. ठीक है, चलो लास्ट पार्ट बोलबो ना, लास्ट पार्ट 1 पार्ट সেটা হচ্ছে স্টোকস ল. स्टोक्स लॉ खूब सोजा, खूब ही सोजा. चलो स्टोक्स लॉ का ये फॉर्मूला लिखो. फोर्स एक्टिंग ऑन अ स्फीयर ऑफ रेडियस r इज गिवन बाय दिस फॉर्मूला. Stokes found it, and this applies good for spherical bodies only, because spherical bodies will have this radius r. Stokes' law applies for spherical bodies only. If a spherical body of radius r is released within a liquid, then what happens? देखो, liquid layers पहले ऐसा था. These are the liquid layers. Okay. Now, if it is an iron ball, suppose of radius r, then if you release it, होगा क्या कि these liquid layers, इसका नीचे जो है उसको ठेल के ये नीचे आ जाएगा. मतलब this liquid layers इसको ठेल के वो नीचे आ जाएगा. This ball will come here. So these liquid layers existing below that will now come here. So what we see that these liquid layers, suppose I am taking these liquid layers together, they have moved in this direction compared to these layers. ये लेयर को मैं बोल रहा हूँ मान लो x, ये लेयर्स को बोल रहा हूँ y, ताले ये लेयर्स को बोल रहा हूँ z. So z liquid layers have a relative velocity with respect to x and y. बोलो ये माने क्लियर हुआ? x and y वहीं पे है, z नीचे आ गया. ताले there is a relative velocity of these liquid layers with respect to the sidewise liquids which are unaffected by the weight of this heavy sphere. So we know that there would be a viscous drag acting on this. एक viscous drag act करेगा किधर? Opposite to the direction of this relative velocity. तो relative velocity किधर है? ये z का नीचे. So viscous drag किधर होगा? Upwards, just trying to oppose this. This would be viscous drag upwards, because if you just take your hand, try to move it inside water like this, you will feel this opposition, viscous drag. कि हाथ का ऊपर कोई force लग रहा है, free नहीं जा रहा है. That means what? There is a viscous drag. Why? The liquid layers below your hand are moving downwards relatively compared to the sidewise layers. So those layers in 3D, those layers will apply upward force just to prevent or trying to prevent this relative motion of the layers below your hand. So that is viscous drag. If you want to do this within Fevicol, then पानी का अंदर जितना easily लेके जा सकते हैं हाथ को, can you drag your hand, I mean move your hand within Fevicol that fast or with less opposition? No. You will experience huge opposition because that is more viscous. So this viscous drag is F, and that depends on the viscosity of that liquid. In place of area, we will consider radius of that sphere and how fast you want to move it below this with relative velocity. How fast means the velocity of that sphere. This formula is given by Stokes. हाँ बोलो. ঠিক বলেছো. বায়ান্সির জন্য আসবে, and we will consider that. We will consider that. But এই পার্টটা ক্লিয়ার. আমরা অ্যাকচুয়ালি এখন বায়ান্সিকে করছি না, আমরা ফোকাস করছি শুধু viscous drag কতটা হবে. But buoyancy would be there. Okay. So that viscous drag would be given by this. And if we consider buoyancy, then what will happen? This is the last part. 5 minutes chuti. But this will be over. But try to understand this. Huh? What we need to understand from here, just एक point मैं बोलता हूँ ये स्टार देके जो लिखता हूँ ना, for ideas. क्या? Suppose if a ball, a sphere moves below through a viscous liquid, तो कितना भी फास्ट जाए या तो स्लो जाए, eta will remain the same, coefficient of viscosity, इसका radius will remain the same, radius of the sphere, ये दोनों तो सेम ही रहेगा ना, ताले all these things will be constant. Then this viscous drag is proportional to velocity. So faster you want to move it, more will be the viscous drag offered. ठीक है, बस ये आइडिया लेके लास्ट थ्योरी में जा रहे हैं. ये थ्योरी का नाम दो, माने सबसे ज़्यादा दिस पर सबसे ज़्यादा चांस है क्वेश्चन का. अब जो करने जा रहे हैं सारा कंसंट्रेशन एक साथ कर दो 5 मिनट्स. बट दिस इज मोस्ट इंपॉर्टेंट आउट ऑफ वॉट एवर वी हैव डन फॉर दिस पार्ट. लास्ट पार्ट, दैट इज व्हाट, दैट इज डेरिवेशन ऑफ টার্মিনাল ভেলোসিটি. হ্যাঁ যাচ্ছি, এটা ওকে ওকে চলো. ডেরিভেশন অফ টার্মিনাল ভেলোসিটি. See, I'm telling you what happens for that picture only. If we have a sphere of radius r, we have let it fall through a viscous liquid. And at any moment, its center is moving with a velocity v. What happens initially? So number one, right, initially mg, well, लोहा का बॉल है, much greater than Facebook will. It's not Facebook. F plus B. What is F? What is B? When it is completely within a liquid, see, if it is even not moving, then also a buoyant force acts on it. Buoyant force, that is buoyancy. And mg obviously acts on it. Let us understand the force diagram. Buoyancy and mg. Now, whatever we learnt in this chapter, that if it is moving through a viscous liquid, the viscous liquid also offers from all sides. Actually, this force acts from all sides. You understand? All sides. It's not double the force. If you draw two arrows, then 2 into viscous force, it will not be there. Actually, the viscous force on this sphere is from all sides. Consider my fingers to be the direction of all the forces. This is all are viscous forces. So total viscous force upward is F. So you can draw 2 arrows upward to indicate F, but they do not make it 2F because the total force upwards is F. Anyway, there is a doubt that comes in students' mind. So total force upwards is F, total buoyancy offered by the viscous liquid, that is B, but weight is much heavier than that. So it is moving down. So as we see, downward force is greater than upward force. So greater force minus smaller force equals to MA. That means the sphere accelerates. Number 2, hence the velocity goes on increasing. Number 3, therefore, remember this point. More the velocity, more the viscous drag, Stokes' law. So therefore, from Stokes' law, viscous drag also increases as F proportional to V. Number 4, here it is the main part. Last part, we have reached the calculation part. The next part is, once the downward force, that is mg, becomes equal to F plus B. That means what? B remains B, but F goes on increasing as the velocity increases with the falling sphere. So F plus B together, suppose initially B was suppose 5, F was suppose 10, but mg was suppose 20. So this was greater. But with time, with velocity being increased, the value of force increases from 10 to 11, 11 to 12, 12 to 13, 13 to 14, 14 to 15. Now what happens? The viscous drag has become 15 and the buoyancy still remains 5. So they together become 20 and mg was already always 20. So now these two become equal. That's what I want to say. So viscous force has started increasing as velocity was increasing, and once it becomes so high that buoyancy and viscous drag together equal to mg, then what will happen? No resultant force. So further acceleration will be how much? 0. Acceleration further will be 0. That means जितना velocity मिल गया है ठीक है, high velocity मिल गया है ठीक है, but from now on upward force and downward forces are equal. So acceleration is not there. That means it will continue to move with same constant velocity it has gained after falling this height. Number 5. That is the point, you write it in words. Hence, the velocity of the sphere, becomes uniform, that is constant. This velocity is called terminal velocity. This velocity is called terminal velocity. Okay. This velocity is called terminal velocity, which remains uniform. ये याद रखना. It becomes uniform. But अब 2 लाइन का बस अब 2 लाइन का कैलकुलेशन, क्लास खत्म. You have written this? Now, calculation part is this. लिखो when V equals to V terminal. बस 2 lines of calculation that you like to do and we get the answer. When V equals to Vt, then what happens? mg downward equals to F plus B. Let us put the values. mg, it is a sphere, volume, density of the solid G. Declaration, rho is the density of solid, that is density of the sphere, and there is another density to be considered, sigma. This is density of the liquid. These are the 2 densities to be considered and remembered. Solid का, that is sphere का rho और liquid का sigma. So sphere का weight mg, यहाँ पे sphere का ही density आएगा, equals to F 6 pi eta r Vt. V becomes Vt now, plus B. B is buoyancy. Buoyancy is 4/3 pi r cube into density किसका लेंगे अब, liquid का, because buoyancy is offered by the liquid, into G. हो गया. Now, if we take 4/3 pi r cube part common into G common, then we can bring this rho का साथ sigma on same side. 4/3 pi r cube G into rho, 4/3 pi r cube G into sigma. This taken on left side becomes negative and this part taken common. Right side में क्या बचा? 6 pi eta r vt. करना क्या है, just find vt, आंसर खत्म, लास्ट लाइन, just find vt. how, ढिचकाओ कर लो पहले. So this is 2 and this 3 and 3 make 9. So Vt equals to, write this in this way so that you can remember it. The factor part 2 by 9. Another thing, you can cancel one r also. This is r, this is r cube. So r square will remain. So 2 by 9 r square g into ब्रैकेट में रो माइनस सिग्मा. रो इज द डेंसिटी ऑफ द स्फीयर, सिग्मा इज द डेंसिटी ऑफ द लिक्विड, डिवाइडेड बाय ईटा. खत्म. दिस मच वुड बी द टर्मिनल वेलोसिटी ऑफ अ स्फीयर when it falls a great height. I mean, it has to be allowed to fall up to that height so that it can attain its terminal velocity. If you stop the sphere before that, then it cannot attain. तो इतना डिस्टेंस कहाँ मिलेगा कि गिरता ही जाएगा. Rain drops falling through air. For those raindrops, this thing will happen. And again, you will get idea of this in class 12 magnetic field, charged particles. So this idea is necessary. So examples are raindrops. You may face some numericals, very easy numericals with raindrops. And फिर से star part, star means idea के लिए. क्या है? इसको लिख के रखो. You will solve numericals in चुटकी में. Next class we will discuss this. Bye.